Okay, so we're going to talk about linear functions and slope. This is sections 2.3 and 2.4 in your text. So slope is the way that you measure the steepness of a line. The number that we assign that tells you how steep a line is. It compares the vertical change, the rise, to the horizontal change, which we call the run, between 2 points on the same line. Change in y over change in x, or rise over run, or subtract the y's divided by subtract the x's. Okay. As long as that denominator x2 minus x1 is non-zero, we have a number that represents the steepness of the line. Okay, so we're going to find the line, the slope of a line passing through 2 points. So we've got -3, 4, plot that point, and -4, -2. So there's my line through those 2 points, and I would like to calculate its slope. So how do I do that? Six, I'm hearing 6. How do you get 6? Yeah, so you can look at it graphically and you can say, okay, between these 2 points, compare how far up we traveled, right, which is 6, to how far over we traveled, which is 1, the rise over the run, 6 over 1, which is 6, right? We also could have done it algebraically by doing 4 minus -2, right, subtract the y's, divided by -3 minus -4, subtract the x's, and that comes out to 6 over 1. Okay, so this should feel familiar. I want you to find the slope for part B. All right, what did you get? -7/5? Okay, so let's see. If I was going to do it algebraically, I would just say -2 minus 5, right? The y, subtract the y's, divided by, subtract the x's, 4 minus -1. So that's -7 over 5. Good. And if I was going to do it graphically, I would plot 4, -2, and -1, 5, and connect them with like a right triangle, and then compare the rise and the run. You could just count. You can go 1, 2, 3, 4, 5, 6, 7 is the rise, and then we went 1, 2, 3, 4, 5 is the run. And it's negative because when you connect those two lines, when you connect those 2 points, that's a line that's decreasing, so it's got to have negative slope. All right, what about C? What's the slope of this line? 0. Yeah, if we pick any 2 points on this line, so this would be -5, 0, and let's say 0, 3, and sorry, that's not the coordinates of that point. That's -5, 3. So when I do the subtraction, when I do the algebraic method, I subtract the y's, I get 3 minus 3 over -5 minus 0, so I get 0 over -5. What is 0 over -5? 0. Yep, 0 over anything is 0. So this slope comes out to be 0. What about this guy? The slope does not exist. The slope is undefined. Yeah, it's undefined because if we pick 2 points, like here's -3, 4, and here's -3, 0. When I do the algebraic method here, when I subtract the y's, I get 4 minus 0. Subtract the x's, and I get -3 minus -3, which ends up being 4 over 0. But you can't divide by 0, right? So the number that we would use to describe the steepness of this line just doesn't exist. You can't divide by 0. So we say the slope of a vertical line is undefined because the change in x would be 0 for any vertical line. So a line that has positive slope Look at the first example. This line has positive slope. It's increasing. If you read it from left to right, it's increasing. And the line that had negative slope, when you look from left to right, it is decreasing. So positive increasing, negative decreasing, zero slope, slope of 0. How do you explain, what word do you use to describe this line? Horizontal or constant? Yep. And undefined slope is a vertical line. So here's just a little summary. Positive slope, increasing, negative slope, decreasing, zero slope, horizontal, undefined slope, vertical. Which of these which of these 4 pictures is not a function? The undefined, why? It doesn't pass the vertical line test, yeah. This guy is not a function, right? Because for the input x right here, whatever this is, x equals something, right? You have an infinite number of outputs for that one input, not a function. Okay, so let's talk about the equation of a line. So we now know all about the line slope. We're going to talk about the equation of a line, which comes from its slope. Okay, a line always has the same slope. No matter which 2 points you use to calculate the slope, you'll always get the same thing. So if I choose any 2 points, x1, y1 is going to be a fixed point. I just pick a point. It's got coordinates. It's got numbers. And then we're going to pick a second point, which is I'm going to call x comma y, which is another arbitrary point that can vary, right? Any other point on the line other than my fixed point. And if I calculate the slope between those 2 points, we use m to represent slope. I would subtract the y's, subtract the x's, divide. That's how you get the slope. Okay, so now if you multiply both sides of this equation by x minus x1, what happens when I multiply the left side of the equation by x minus x1? You get a cancellation, right? Those guys cancel. And what you're left with, y minus y1 is equal to the slope times x minus x1. We call that the point slope equation of a line. Point slope form for the equation of a line. x1, y1 represents a specific point, and x and y are variables, right? They change. M represents the constant slope. So let's use this to find an equation in point slope form. So it's going to look like this, right? For a line that meets these conditions. So it has slope 6 and passes through the point 2, negative 5. So if slope is 6, that's my m, right? And any point I can use to be my x1, y1. So I just plug in here. I'm going to have y minus negative 5 equals the slope 6 times x minus x1, which is 2. That's it. That's the equation of a line. If you want, you can change this minus a negative to a plus. So probably you're more familiar with the slope-intercept form of a line, which is what we're going to cover next. And if you really want to use slope-intercept form, you can now just distribute your 6 and subtract 5 from both sides, right? So if you're more familiar with mx plus b, distribute your 6 and you get 6x minus 12. Negative 12 minus 5 is minus 17. This is called the slope-intercept form. This one is the point slope form. All right, so you try one. Find the equation that goes through these 2 points. You got to find the slope between them first, and then you can use either one as your x1, y1. Okay, so the first thing whenever you're finding an equation of a line is to find its slope, right? The last one was easy because they gave it to us. So if I want to find the slope here, I have m equals, and I do subtract the y's and divide by subtract the x's. So I've got -1 minus -6 divided by -2 minus -1. So that comes out to -5. Everybody's got -5? Okay, so now I want to find the equation of the line. The point slope form is y minus y1 equals m times x minus x1. I know m now, so I put in a -5 for the m. And then all I need is an x1 and a y1. That's any point. You can pick either one to be your x1, y1. Maybe this one could be my x1, y1. You can use the other point too, right? Doesn't matter. So I'm going to have x minus -2, so x plus 2 over there. And then for my y's, I have y minus -1. -1 plus 6 is -5, is +5, and -2 plus 1 is -1. So you have a -1 in the denominator, making the whole thing negative. So this is the point slope form. Done, right? You could have used the other point too. So this is interesting because I'll show you that they come out the same. So y plus 1 -5 times x plus 2. Now what if I had used the other point? So I would have y minus something equals -5 times x minus something. -1 and -6. -1, -6, right? So either of those represents the equation of the line where you're using the 2 different points. If I solve these 2 things for y equals, which I did not ask you to do, but if you do that, you end up with y equals, I distribute the -5 and I get -5x minus 10 minus 1 when I move that 1 over. So I have y equals -5x minus 11. And then do the same thing over here, and I get y equals -5x minus 5, distributing the 5. Then subtract 6 from both sides, and I get y equals -5x minus 11. Same thing, no matter which point you choose. Where'd I lose you? Oh, you just made a mistake. Okay. So no matter which point you use, you end up with the same equation of the line. They are equivalent. All right, so let's use slope-intercept form. To develop slope-intercept form, I'm going to use point slope form, but the point I'm going to use is going to be the y-intercept, right? The y-intercept of a line is at 0, b. So I'm going to write y minus y1 equals m times x minus x1, but I'm going to let x1, y1, the point that I plug in, is going to be 0, b, the y-intercept. So this becomes y minus b equals m times x minus 0. So y minus b equals mx. And then add b to both sides. Equation of a line in y-intercept form. So we don't have to go through all of that. Right, yeah, you don't have to go through all of this. I was just showing you where this comes from. Yeah. Yeah, so that is the y-intercept, slope-intercept form of a line. Y equals mx plus b. M is the slope, b is the y-intercept. This is probably the one you guys are most familiar with. The worst form of a line, in my opinion, is called the general form. There's a third form other than point slope, other than slope intercept. Like, you've got to be kidding. How many forms of a line do we have to know? Right, the general form is ax plus by plus c equals 0. But luckily, it's equivalent to the other two. If you just solve that thing for y, you get slope-intercept form. So we don't even really have to think about it. So here's one given in general form. I'm going to graph it in two ways. So the first one is I'm going to change it into slope-intercept form. I'm going to solve for y. So I want to get the y by itself. So I'm going to have 6y is equal to negative 3x minus 12. Right? Just subtract 3x and subtract 12 from both sides. And then what do I do to get the y by itself? Divide by 6. Divide every term on both sides by 6. So we get y is negative 1/2 x minus 2. And then how do you graph that line? The y-intercept is negative 2. And then how do I get another point? Down 1 over 2. Yeah, you can use the slope to get another point. We go down 1 over 2. There's another point on my line. Or you can plug in any value of x you want. The top is the rise and the bottom is the run. So I went down 1 and right 2. Yeah. We also could have gone up 1 and left 2. You land on the same line. Terrible at drawing lines. Sorry. So there's one way to graph that thing. Put it into slope-intercept form, plot the y-intercept, and then use the slope to get another point. I could also graph it by finding the x and y-intercepts. So if I want to find y-intercepts, how do I do that? In general, how do you find a y-intercept of a... Make x 0. Yeah, make x 0. Right, because when you're on the y-axis, the x-coordinate is 0. So we just have to put in a 0 for x. So we have 3 times 0 plus 6y equals 12, and then solve for y. Sorry. Plus 12 equals 0. There we go. So I just replaced the x in the original equation with a 0, and I'm going to solve for y, and you get y equals negative 2. Okay, so there's my y-intercept. And then when I want to find an x-intercept, what do I do to find an x-intercept? Make y 0. Yeah. Because anytime you're on the x-axis, the y-coordinate is 0. So replace your y with a 0, and we have 3x plus 6 times 0 plus 12 equals 0. So I'm just plugging into the original equation a 0 for y. So I solve for x, and I get 3x equals negative 12. So x is negative 4. Plot that point. Connect those two dots. Is that the same line as the one I graphed over here? Yeah. If they're different, it's because I'm terrible at drawing lines. But it's the same line. This guy goes through negative 4. X equals negative 4. So two ways to graph a line, right? You can put it in slope-intercept form, graph the intercept and use the slope, or find the x-intercepts and the y-intercepts. Okay, one last thing. Possible equations for horizontal and vertical lines. So let's just pick a few points on this horizontal line. What are the coordinates of that point? Great, negative 5, 3. How about this point right here? Negative 2, 3. How about this point? 4, 3. Okay. every point on this line has something in common. What do they have in common? Y is 3. That's the equation of the line. Y is 3. Y equals 3 is the equation of this horizontal line. The y coordinate is always 3. We do a similar argument over here. Pick some points. This point is -3, 5. And this point here, -3, 2. This point down here, -3, -4. Every point on this line has an x coordinate of -3. That's the equation of the line. X equals -3. Because the x coordinate is always -3. Okay. Last thing. Parallel and perpendicular lines. Parallel lines always have the same slope. So this first picture demonstrates here are two lines that are parallel. They never intersect. They have the same slope. And perpendicular lines always have opposite reciprocal slopes, right? So this blue line has slope A over B, right? Because the rise is A and the run is B. And then the red line that's perpendicular to it, its slope is -B over A. So that's what opposite reciprocal means. It means flip the fraction over and take the opposite of it, right? If it's positive, make it negative. If it's negative, make it positive. All right, so think about these two for a minute, and we can go over them after. So if I want to write an equation of a line that passes through -2, 5, and is parallel to the line that has equation y equals 3x plus 1, and it says put the equation in point slope form and in slope intercept form. Hey, shh. Okay, so point slope form is y minus y1 equals m times x minus x1. So I need a slope and I need a point to just plug in here. So I've got a point. This will be my x1, y1. What is the slope of this line I'm looking for? 3. How do you know it's 3? Yes, so it's parallel to this line, which means it has the same slope, right? And the slope of that line is 3, because that's in mx plus b form. So I end up doing y minus 5 equals 3 times x minus -2. So that's my point slope form. Done. Right? And then all I have to do is solve for y, and I'll have slope-intercept form. So I can just distribute my 3, y minus 5 equals 3x plus 6, and then add 5 to both sides. 3x plus 11 is the slope-intercept form. All right, so now I want to find the slope, just the slope, not the equation. The slope of any line that's perpendicular to x plus 3y minus 12 equals 0. Well, what is the slope of this line? -1/3. How do you figure that out? You're going to solve it for y. You have to put it in mx plus b form so that you can read the slope from it. So to solve this thing for y, I would say, well, 3y is equal to -x plus 12. And then I divide everything by 3. So y is equal to -1/3 x plus 4. That's the equation of this line. Same line. So the slope of that line is -1/3. So the slope of the line I'm looking for, being perpendicular to this one, is going to be what? 3. You take the reciprocal, means flip the fraction over, and if it's negative, you make it positive. If it's positive, you make it negative. It's negative, so it comes out to +3. All right, good. Okay, last thing is we think about slope as a rate of change when we're doing a problem in context. So we think of it as a rate of change of the dependent variable, that's y, per unit change in the independent variable, which is x. So in applied problems, try to keep track of what units go in the numerator and the denominator. It will really help you when you're interpreting the slope. So in the year 2000, the average price per gallon of gasoline was $1.93, adjusted for inflation. In 2011, the average price was $3.53. Assuming that the price of gas increases linearly, right, so that it's the same amount every year, we want to find an equation that models the price of gasoline G as a function of the year T, measured in years since 2000, and interpret the slope. Okay, so I had 2 points are embedded in that question. What are my 2 points? 0, 193. Why 0 and not 2000? Yes, because they told us we're measuring, T is measured in years since 2000. Okay, what other point is sort of embedded in the sentences here? 11, 353. And those are dollars, right? So if I want to find the slope between these 2 points, I would do 353 minus 193 divided by 11 minus 0. All right. 353 minus 193. What are my units on that subtraction problem? Dollars. And 11 minus 0. What are my units there? Years. Okay, so now when I calculate my slope, I'm going to have a unit on there that's going to help me interpret what that number means. So I do 353 minus 193 and divide by 11. I get 0.14, let's just say 0.15. $0.15 per year. $0.15 per 1 year, right? So interpret what that slope means. What does that 0.15 mean? The price of gas increases by 15 cents each year. So that's what I'm going to be looking for on your project, right? You're going to have to tell me what the slope is and what it means. So you would have to write a full sentence to explain it. The price of gas increases by 15 cents each year. So having the units, when you do the calculation of saying, oh, 353 minus $1.93, that's, my units there is dollars. My units in the denominator is years. So that helps you, when you look at the units on the result, dollars per year, that helps you, really helps you write out the sentence of what that number means. $0.15 per year. Oh, that's how the price of gas is changing. Okay, so I'm not quite done with the question. They asked me to write an equation for this line, right? Yeah, find an equation that models the price of gas as a function of year. Okay, so I now know the slope. So my equation would be y minus y1 m times x minus x1. Maybe I'll use $1.93 and 0.15 times x minus, what should I put there? 0. There's the x that goes with the $1.93. And then I could solve this thing for y if I want, or I can just leave it like this.